Hello and welcome to our tutorial today. Today I'm going to show to you the topic of benzene. All right, the topic of organic chemistry is in benzene. Benzene. So what are the properties of benzene? The properties of benzene is actually an aromatic. It's actually aromatic hydrocarbon. All right, it's actually an aromatic hydrocarbon with chemical formula of C6H6. All right. And then it also has a it has a colorless liquid. It's actually in the form of colorless liquid at room temperature. Okay, RTP, room temperature and pressure. All right, and then it's very unreactive. Why is it unreactive? It is actually due to strong bonding. All right, due to strong bonding uh, within the structure, within its structure. And then usually or oftentimes we use benzene as a non-polar solvent. That's why most of the non-polar organic molecule will be able to dissolve in benzene. However, due to carcinogenic of benzene, it's no longer used. Yeah. All right. So let me draw the structures of benzene. All right. Let me draw the structures of benzene. The structures of benzene, it will be look like this one. All right. I'll show you the structures of benzene. It will be look like this. Sorry. Excuse me for technical issue. So it will be look like this one. All right. So the structure of benzene, it has a double bond, single bond, double bond. All right. And then if we number this benzene, then I will have carbon number 1, carbon number 2, 3, 4, 5, and 6. So carbon number double bond in carbon number 1 can move to number 2 and 3. The double bond in carbon number 2 and 3 can be moved to carbon number 4 and 5. The double bond in carbon number 5 and 6 moves to number 1 and 6. 1 and 6. So I will have another structures of this one. So this one move there, this one move here, and the other one move here. Okay. So if I keep on doing this, right? So if this electron keeps on moving, then I will have the initial structures of benzene like I have in the first one. So basically, this is carbon number 1, 2, 3, 4, 5, and 6. All right. So instead of writing this kind of movement, we call one resonance. Then I can use the simple form is like this one. Okay. It can be represented by this diagram. So basically, I can use a circle. All right, I can use a circle here, right? Okay, so to represent the movement of electron. Okay, so what does it mean? What is the circle? What is the inner circle that I have here in the in this structure? So it's actually the regions of high concentration of electrons. So meaning inside this circle, the electron is resonance, right? The resonance of electrons makes the benzene is very unstable. Yeah, I mean, sorry, unreactive, right? So the unreactivity or unreactiveness of benzene is due to the high concentration of electron here. Therefore, all right, so if I may add here, I add one more. Therefore, benzene against, okay, benzene favors substitution reaction. Substitution reaction. So instead of even I know some of you already know that if you have double bond, the tendency for organic molecule to experience addition reaction, which is the breaking of double bond, then of course it will give you breaking of double bond become single bond. However, because of the resonance, that we have in benzene, the resonance properties of benzene, making it less attracted to addition reactions, but it's actually it favors to substitution reaction. Okay, all right. Now, talking about substitution reaction, I have a of course we have substituent group. Okay, substituent group, and then I also have systematic name. All right, systematic name. Okay, so to help you to understand uh, the how the how many how hydrogen in benzene can be replaced. All right. So if I have a substituent group, right? So for example, I have methyl, right? Then methyl is actually CH3. Then if I replace one hydrogen with CH3, then I will have, okay, the systematic name. So it will be methyl benzene. Okay, it will give me methyl benzene. Okay, so if the substituent group is actually chloro, okay, chloro, which is Cl, then I will have chlorobenzene. All right, I will have a chlorobenzene. And then if my another substituent is actually hydroxyl, which is OH, then the name will be phenol, right? If my substituent is actually nitro, or it is NO2, then the systematic name is actually nitrobenzene. If my substituent is actually amino, okay, the chemical formula of amino is NS2, then I will have phenylbenzene or phenylamine. And then if I have another one which is carboxylic acid, just put Ca, carboxylic acid, which is COH, then I will have benzoic acid. All right. So again, let me repeat one more time. Benzene has is actually an aromatic hydrocarbon, colorless liquid, unreactive, nonpolar, favors for substitution, and then these are the list of substituent group and the systematic name. And then the other thing that you need to remember is actually the bond length. Okay, since you have a double bond and single bond here, right? Let me use another color. So since we have a double bond and single bond, all right. So please note that the length of double bond, okay, the length of double bond is shorter than bond length of single bond. Okay, so this is double bond. single bond. Uh, yeah, I believe that you already learned um, got quite number of introductions of benzene, and I hope you can learn. And then thank you for watching.